Today we're going to talk about standing wave and a force, tension force. If the string has a mass of 40 grams, what tension force is required to produce such a wave? So I didn't have the given here, but the velocity here is going to be 30 meters per second. So in order to calculate the tension force here, what we need to do is use this equation. And we need to first calculate the linear density. So the linear density, the mass must be in kilograms and the length of the string must be in meters. So that's the standard formulas. So we could just change this up. Now we could just divide this. We still need to convert 40 grams into kilograms. So we just need to divide this by 1000. So in 1 kilogram we have 1000 grams. Okay, what you need to do is cancel the grams here. So what we got is 0.04 kilograms. Then we can just divide this linear density. That's going to be 0.13 repeating. So that's going to be the linear density. Then we can just arrange our equation and isolate the tension force. So that's what we're going to calculate. I didn't have the given of the velocity of the string, but suppose let's just assume that's going to be 30 meters per second. So we got p squared and linear density here. So tension force is going to be the velocity produced by the wave by the string, and let's say that's going to be 30 meters per second. So that's going to be 30 squared multiplied by 0.13 repeating. So the tension force here is going to be 120 newtons. Now let's try this one. The tension force is of 300 newtons was applied to a 0.75 kilogram string that is 5 meters long. A standing wave with 5 loops was produced. Calculate the speed, wavelength, frequency, fundamental frequency, and the first 3 overtone. So if we're going to calculate the velocity or the speed of this standing wave, we could just plug in everything what we know. So we have tension force of 300 newtons that was applied. We also have 1.75 kilograms of string, and it's going to be 5 meters long. So the velocity here is just going to be 20 root 5 meters per second. Now let's calculate the wavelength. So the wavelength that depends on the number of nodes. It's going to be 2L divided by N. So we have 5 loops here. So let's calculate its wavelength in 5 loops. So we got 2 times 5. It's going to be the length of the string divided by 5. You can just cancel the 5, leaving us with a wavelength of 2. Now let's calculate the frequency. So we already know what's the velocity. We can just easily calculate the frequency at the 5th node. Ouch. So velocity is equal to frequency times wavelength. We can just calculate the wavelength here with the frequency times number sub 5. So we can just divide this. So we got 20 root 5 divided by 2. So it's going to be the frequency. It's going to be 10 root 5. This is the frequency at 5th node. Now let's calculate the fundamental frequency. So the fundamental frequency is the frequency at the first node. That's going to be f sub n times n times f sub 1. Then we can just isolate f sub 1. We already have the given of f sub n. F sub 5 is going to be 10 root 5. And we're going to divide it by 5 too. So we got 1. It's going to be 2 root 5. Now let's calculate the last one. The first three overtones. So the overtones is going to be n plus 1. Meaning we're going to calculate it at the second nodes. Second node, third node, and fourth node. That's going to be equal to overtones 1, 2, and 3. So the frequencies sub 2 is going to be twice the fundamental frequency. And the fundamental frequency, I just forgot it, I just deleted it. Go to 2 root 5 multiplied by 2. It's going to be 4 root 5. Now, the second overtone is going to multiply the 2 root 5 by 6. It's going to be 6 root 5 hertz. And we can just calculate the f sub 4. So that's equal to f sub 1, 2 root 5 times 4. So f sub 4 is going to be 8 root 5 hertz.